Alright folks, so we're just going to continue on with the remainder theorem. So, what is remainder theorem? So we have this idea here that basically says if the polynomial, whatever our polynomial is, divided by x minus a, the remainder is whatever the subbed in a value into that polynomial is. So it's just a quick way to double check if we have a remainder. So calculate the remainder when. So we're looking at this polynomial here. I want to see what my remainder is, so I do a quick sub in. So x minus 2, so I'm just going to isolate for x there, so that's x equals positive 2, and let me jot that down. So I have x minus 2, I'm going to equal to 0, so x equals positive 2, and from there I'm going to sub in into my polynomial, so p at 2 there is going to be equal to 4, 2 cubed minus 11, 2 squared plus 12, and I'm looking to see what my remainder is. So here this cleans up to be 32 minus, so that's 4 and 11 makes 44 and 12. And of course if you add, subtract and add again, we end up with 0. Therefore we actually don't have a remainder in this first example. There we go. We don't have any remainder in this first one. So in the second one here, if I took this equation and I'm dividing it by x plus 1, do I have a remainder? Yes or no? Let's find out. So first things first, x plus 1, I need to isolate. So I'm going to go x equals negative 1. So now I'm going to sub in p at negative 1 because p is polynomial. Polynomial at negative 1, what do we have? We have 2. Negative 1 exponent 4 minus 3, negative 1 squared, plus negative 1 in bracket, minus 1. Let's see what we end up getting here. In this case here, that's just going to be 2. This one here is just going to be minus 3, minus 1, minus 1. And so here, if we added all of this up, you end up with negative 3. Therefore, in this case, if you took this polynomial, divided it by x plus 1, you'll have a remainder equal to negative 3. In our next example, we're going to take a look at this polynomial. It says here if we divide it, or is divided by x minus 3, the remainder is 12. So I'm telling you the answer is 12. What's the value of k though? So we just got to do a quick substitution to figure out that value there. So I'm going to set up this equation. So we know we're looking at p, and it says here in the note p3, because this is x minus 3, rewriting that's x equals 3. And this is equal to 12. Well, how did we ultimately get to 12? I'm going to sub in 3 into every single x value in this polynomial. So I have 3 cubed minus, and I'm going to put k there in a different color just so that it stands out a little, 3 squared plus 17 times 3 plus 6 there. Alright. So here I can drop my polynomial function there. I'm just going to start off with 12 right away. This here, of course, is going to be 27. 9 and k make 9k, so I'm going to go minus 9k here. We have 17 and 3 make 51, and that plus 6. Ultimately, I want to get k by itself, so I'm going to move all the numbers all to the left here. If I move all my numbers all to the left, I get minus 72 equals negative 9k. So therefore, k has to equal, if you divide both sides by negative 9, k has to equal positive 8. You could do a quick check by subbing in positive 8 into this polynomial, doing the remainder theorem again, and you're looking for an answer of 12, which of course it should work out. In this last example here, what we're doing is we have a polynomial, we're dividing it, and I gave you the remainder of the first division. You take that same polynomial, you divide it again, you're going to get this for a remainder. So two different remainders right now. What's the value of m and n ultimately? So I'm going to split up my screen really quickly here. There we go. And I'm going to start subbing in some of these values. Well, what do I have? I have p at 2. P at 2 is equal to negative 3. So I'm going to say 3. Every single x I see right now, I'm going to write down the number 2 in this polynomial. Let's m 2 squared plus n 2 minus 7. And of course, all of this, when you first divided it, it says a remainder is negative 3, so I'm going to say equals negative 3. Let's clean this up really quickly. This is now 24. This is now 4m. Over here, you have plus 2n minus 7 equals negative 3. I want to get m and n by themselves because it's my only variables right now, so I'm going to move all my numbers all to the right side here. So I have 4m plus 2n. So now that's going to equal negative 20. I'm going to do the exact same thing, but just over here, because we have a different division statement, so I'm going to go with p at negative 1. So basically, p at negative 1 was this side here. P at 2 was on this side here. Okay. So let's see what happens at p at negative 1. So you have 3 negative 1 cubed plus m times negative 1 squared plus n at negative 1, and of course minus 7. All of this is going to equal our remainder of negative 18. There we go. And again, I want to clean this up before I move on. So on this side I have negative 3 plus m minus n minus 7 is equal to negative 18. Moving everything away from m and n. So I have m and n still is equal to, and on the other side, negative 8. From here, if we're looking to solve for m and n, this is called your systems of equations. So I'm going to just either solve by substitution or solve by elimination. And hopefully those two keywords sound familiar to you. So I'm just going to write a quick note. So note, solve by substitution or elimination, and these two concepts were from 10C, so you're definitely going to need to brush up on a bit of your 10C. I'm going to choose to solve by elimination here. So what does that look like? That means I'm going to double stack my equation. So my first equation here is 4m plus 2n minus 20, sorry, is equal to negative 20. And my second equation, m minus n, is equal to negative 8. From here, to eliminate my variables, I'm just going to pick one of them to eliminate. So I'm going to pick n, and the way I eliminate is multiply by 2 because I have a coefficient of 2 there. I want to match up down here. I'm going to quickly rewrite below here. So I have 4m plus 2n equals negative 20. And once I multiply 2 into everything inside the bracket here, you have 2m minus 2n this time equals negative 16. To eliminate, I'm going to, in this case here, my n's are the same coefficients. One's a positive, one's a negative. I'm going to put a big fat addition sign here as my function, big equal sign underneath. Adding these together, I have 6m. My n's would cancel out because I got 2 plus negative 2, and that my equal sign follows, and I got negative 36 here. To get m by itself, dividing everything by 6 gets you negative 6. There we go. Let's find the letter n. And I'm going to go back to one of the equations. I have m minus n equals negative 8. I know m was negative 6, so I'm going to write down negative 6 here in brackets, just because that's my sub in. I got minus n equals negative 8. Moving that 6 to the other side, I got negative n equals negative 2. And of course, two negatives are going to cancel, so I got n equals positive 2. And there you go, folks. That is our answer for this one. N equals 2 and m equals negative 6. And that's the end of our remainder theorem.